I have all the components glued into place now, and we're ready to do the electrical wiring. Now, I mentioned the online instructions before. I recommend that when you do your wiring, you refer to the online instructions because they'll provide more detail than what I'll be providing here. Now I'm going to make the electrical connections to the components on the framework. For that purpose, I have 4 pieces of hookup wire. If you're using our crossbeam Photogate kit, these pieces of wire come with that kit. I also have my wiring diagram, which I printed off of the web, also part of the kit. I have a section of 3-conductor cable which will be used to connect the Photogate frame to the breadboard circuit, and the instructions for building the circuit are on the web. Those parts come with the kit as well. And I have a section of 2-conductor cable which is used to connect the trigger to the output of the trigger to your flash or camera. And for tools, wire strippers, needle nose pliers, and soldering iron. And so I'm ready to go. What I'm going to do first is solder the yellow wire to the LED on one end and to a photo transistor on the other end. So let's do that now. I've wrapped the yellow wire around the shorter leg of this LED and the longer leg of this photo transistor. Now I'm going to solder those 2 connections. Turn on my exhaust fan. I have the yellow wire soldered, and now I'll do the other 3. I have my 4 hookup wires attached and soldered. Except for these right here, I haven't soldered them yet because I'm going to be connecting my 3-conductor cable to it first. So to get the 3-conductor cable ready so that we can connect the framework to the trigger, first thing I want to do is strip back a distance about half of one side of the frame. And then of the 3 conductors, I'll strip those back about a ½ an inch each. And I'm going to wrap those around the appropriate legs on the components. All right, the red one is going to go around the longer leg of this LED. And then the black and the green ones are going to go on this photo transistor here. Now I have everything wired to the framework, and the next step is to take the wires down so that they're not prone to being pulled out. For each of the components, spread the legs apart and push them down to make sure that they can't touch each other. Then use electrical tape and wind it around each leg in order to hold it in place. Also use electrical tape along the length of the wire all the way around the framework in order to make it nice and secure. I'll do that now. Well, the gate is ready to go. I have it connected to the breadboard and a battery attached. So let's see how it works. When I break the intersection of the 2 beams, the red LED, which is an indicator, should go on. As you can see, it doesn't. Well, that was intentional because I wanted to show you what the effect is of the ambient light in the room. The room is too bright for the sensitivity adjustment that I currently have. So when the light is turned off, and now when I break the beam, you can see the red LED goes on, okay? So obviously if you're working outdoors, you can't be turning the sun on and off. So what you need is another method for making the gate work. And you do that using the sensitivity adjustment. This brown knob is a coarse adjustment and the white knob is a fine adjustment. I'm going to turn down the brown knob to the point where the red LED comes on by itself. That means the gate is too sensitive. So I'm going to back it off from that just a little bit. Okay. So now it's just on the threshold of working. Now when I break the beam, the red LED comes on. So that's how you would go about adjusting the sensitivity of the gate. Now, if you're working outdoors, you may and the light is bright, you may find that you have to turn the brown sensitivity knob all the way down to 0 and do all of your adjustments with the fine white knob. Okay, I find that I have to do that. In fact, if I have my gate set up and I leave it set up during the day, as the light level changes from the sun rising in the morning to bright light in the middle of the day and then into the evening, I will have to go out several times and make adjustments to the sensitivity to make sure that the gate is still working. All right, now the last thing is to connect this to your flash unit or to your camera, and that's what the 2-conductor cable is for. Again, to see all the connections and where to make them, go to the online instructions for that purpose. But one end of my 2-conductor cable would connect into the breadboard, and then the other end, if I were triggering a flash directly, then I would want to splice this to either a PC cord or to a flash foot adapter. But most people will probably be going from the output of the circuit to their camera because they'll be working in daylight conditions. So in that case, this needs to be spliced to the remote shutter release cable of your camera. All right, next we're going to take this outdoors and see what it looks like when it's all set up. Here's the setup on my porch. I have the gate connected to a light stand between my 2 bird feeders. Every so often a bird will pass through the gate and set off the 2 flashes. The flashes are Vivitar 283 set for low power, and they're synchronized with the camera shutter. The camera is a Nikon D200 with an 18 to 200 millimeter lens. The aperture is f16 and the shutter speed 1/250th of a second. Here are the electronics down here on the porch along with all the bird seed. Everything is powered by AC. I even use an AC adapter with the trigger circuit, and this is because I may leave this set up all day long, and I need to have it keep working. As I mentioned before, every so often I need to come out here and adjust the sensitivity of the trigger circuit if the light level changes. Today is a rainy day, so we're not getting much of a change in light level.